All right, number 17 off the review packet. Okay, we're finding the tension in each cable supporting this 600 Newton burglar, this robber hanging here from this rope. Now, the key to this problem is we're going to focus right here where the three ropes come together, right? So let's just label these tensions. Let's label the tensions. Let's say that the tension in this rope is T1, the tension in this rope is T2, and the tension in this rope right here is T3, okay? Just so we can talk about it. T3 is super easy to figure out because if you look at this robber hanging right here, so here he is, right? Here's the guy hanging there. So we got 600 newtons down, and then what's holding him up? The rope, T3, right? If he's just hanging there, if the burglar is just hanging there, this force and that force must be equal. So we know right off the bat that tension 3 is equal to 600 newtons, right? This force right here is 600 newtons because if you look at the burglar, the down force of his weight must equal the up force of tension 3. Does that make sense? Okay, so now I'm just going to redraw this free body diagram. So what I did right here, I'm just going to redraw right here. So this point right here represents this point right there. So we have tension 1 pulling up like this. We got tension 2 pulling to the left. And we got tension 3 pulling straight down. And then this angle in here, well look, if this is 37 degrees up here, if that's 37 degrees, then what must this be? 37 degrees. Alternate interior angles. That's what they called it when I was taking math. Do they still call it that? Yeah. Alternate interior. Okay, now, the key to this problem, and T3 is equal to 600 newtons. Okay, the key to this problem is summing forces. X direction, Y direction. Now, how many forces do we have in the X direction? Not one, two. Now, the tricky thing here is T1, because does T1 point perfectly X or perfectly Y, or both? Both. So look, this is the X direction, this is the X direction, this is the Y direction. T1 has X component and Y component. So we got to use trig to get those components. Okay? So, in the X direction, what are the two forces in the X direction? We have the X component of T1 and then T2. Those are the two X forces. So how do we get this X component of T1 right here? That's going to be cosine 37 T1. And then how about the Y component? Sine 37 T1. All right, so summing the forces in the X direction. And don't forget sign conventions. To the right is plus, to the left is minus, up plus, down minus. There's the sign convention. So what are we going to make this dude right here? Plus. Okay, so that's going to be positive cosine 37 T1. That's this guy. And then we say minus T2. Why did I make T2 minus? Because T2 points which way? To the left. Now, any other forces in the X direction? Nope. So what is the sum of the forces always equal? MA. Okay, that's why basically, guys, this final exam, like when you're 20 years from now, when you're almost as old as me, you'll be like, what do I remember about physics? What should you remember about physics? F equals MA, motion stuff, kinematics. So I'm giving you the final is going to be like the basics of the fundamentals of physics. All right, what is this acceleration? What's this burglar doing? Is he accelerating or hanging there? He's hanging there. So what's this acceleration? 0. That's an X acceleration. It goes to 0, right? So technically it equals MA, but the A is 0. So we just wrote a very useful equation. Now, go to the Y direction. In the Y direction, how many forces do we have? We got this guy and we got this guy. Those are the two y forces. The up one is plus and the down one is minus. So it's going to look like this. We're going to have sine 37 T1 minus 600. Sum of the forces equals ma, where that's a y acceleration. But is this guy accelerating vertically in the y direction? No. So we can take the y acceleration, set it to 0. There is no y acceleration. Okay, so dudes, the hard part's done. Look at this y equation. What can we easily solve for in this y equation? T1. So you do the algebra. T1 comes out as 997 from the y equation. Once you have that, once you got T1, what do? Plug it in up there, and now you can solve for T2. T2 comes out as 796.2. All right, and then we already know T3. So basically here are the answers. Tension 1, 997. Tension 2, 796.2. And then T3 was the first one we figured out. Does everybody see why that has to be 600? Yep. So if you focus on that burglar right there, here he is. Here's the burglar. You got 600 newtons down, and then what force is holding him up? T3. They have to be equal because he's just hanging there. So those are the answers.